In this chapter, we will be looking at some preliminary concepts in trigonometry. In this lesson, we will be looking at the unit circle and exact values. To begin, we will look specifically at the unit circle.
Okay, so when we use the word unit in mathematics, we are talking about the number 1 here. So the unit circle here is a circle with a radius of 1 unit. Okay? And in this case, it's going to be centered on the origin. And so we get here the coordinates as we go along around the unit circle and we intersect the axes. We get 1, 0 here, then 0, 1, negative 1, 0, 0, negative 1. Those are really important points there, and I'll explain why in just a second. Okay, now the equation of the unit circle is actually quite simple here. When you draw, we'll go down here, when you draw a radius out to a point on the unit circle, okay, you hit the circle at the point x comma y. Notice that you can drop that altitude. We've been doing this already. You can build a triangle, x and y. But notice that the relationship between those two, well, these three sides here, is really just summed up nicely in the Pythagorean theorem. And so the equation of the unit circle is going to be x squared plus y squared now equals r squared, but in this case, the radius is just 1. So x squared plus y squared is equal to 1. Now, you need to know that, okay? That should just be memorized, okay? It should be knee-jerk reaction to you. When you talk about the unit circle, that's what you're talking about, okay? So you know that. Now, all the points, p, x, y, on the unit circle satisfy that equation. Now, what's interesting about those points, though, because the radius is equal to 1, now think back to our definitions here, and man, I cannot overstate how important this is. When you think back to our definitions, remember that the cosine of theta was x over r, okay? So any given, I guess, circle, any radius here, you take the x-coordinate divided by the radius, that's the cosine of the angle that goes through that point there. Sine of theta was y over r. Same thing. Now, on the unit circle, though, when that radius is equal to 1, that makes the cosine of theta equal to the x-coordinate. And that makes the sine of theta equal to the y-coordinate. In fact, one way of defining sine and cosine for angles is quite literally the coordinates of the points on the unit circle that terminal arm goes through. Okay, so you pick any specific terminal arm. Okay, let's throw out an angle here, for example. Okay, we'll kind of come over here. Let's say, for example, we're going to let theta equal to, let's say, 150. Okay, because we've been working with this one before here. Along the unit circle, okay, if this is the unit circle, so r is equal to 1. When we go out to this point right here, if this is 150 degrees, then the coordinates of this point right here will be the cosine of 150 degrees, comma, the sine of 150 degrees. Okay? Zoom in maybe a little bit more than that. So it doesn't matter what the angle is. Okay? The coordinates along the unit circle that terminal arm goes through will be the cosine of that angle and the sine of that angle. That is what's really special about that unit circle here. And that's summed up in this point right now. Therefore, the point xy represents those coordinates, cosine of theta, sine of theta.
Does the point negative 3 over 4, comma, root 7 over 4 lie on the unit circle?
All right, well, to answer this question is very simple. We just apply it to the equation of the unit circle. So I've got x squared plus y squared is equal to 1. Let's just check and see. So negative 3 over 4 squared plus root 7 over 4 squared. Does that equal 1? I don't know at this point here. So negative 3/4 squared will be 9 over 16. Root 7 over 4 squared is going to be 7 over 16. Does that equal 1? I don't know. It's an unknown all the way down there. Well, the denominator is the same. 9 plus 7 is 16 over 16. And so, yes, that equals 1. So the answer to this question is yes. That point must be on the unit circle. It satisfies the equation.
If the point x comma point 8 lies on the unit circle, find all possible x-coordinates.
So in this case here, we're assuming this point lies on the unit circle. Now, it says find all possible x-coordinates. Okay, I want to be a little strategic in this. I want to kind of have an idea of how many I'm looking at before I even do this. So let's just take a quick look. Okay, here's our unit circle. And remember, this goes up to 1, down to -1, over to 1, over to -1 here. Now, I know that the y-coordinate here is positive 0.8. Now, 0.8 is going to be somewhere up here. So that maybe corresponds to a horizontal line that does this. Okay, so this is where y is equal to 0.8, which tells me I'm going to have just the two possible answers there. And based on the symmetry that I'm seeing, probably the positive and negative value of the same number here. Now, let's plug these things in to the unit circle. So remember, that's x squared plus y squared is equal to 1. I don't know what x is. I know that y is 0.8. So 0.8 squared is going to be 0.64 equals 1. So I'll bring the 0.64 over. So x squared is going to equal 0.36. And now when I take the square root of that, okay, remember that I'm getting plus or minus, and then the square root of 0.36, which is going to be plus or minus 0.6. And so that plus or minus actually corresponds directly with my assumption right at the beginning here that there's some symmetry. And so that works out really, really quite nicely. So plus or minus 0.6.
If the point -2 root 5 over 5, comma y, lies on the unit circle in quadrant 3, find the value of y.
Okay, so in this case, we're given a little bit more information here. So we've got this particular point here. We're told that it lies on the unit circle. Okay, so now let's draw this out just to get a sense of what this is going to look like here. -2 root 5 over 5, okay, that's as my x-coordinate, that's going to be somewhere over here. I don't know exactly where, but that's going to give me this line here, okay, x equals -2 root 5 over 5. Now notice that there are two values of y that would satisfy that. So I'm expecting two values here, but the question specifically tells me that I'm looking in quadrant 3. So that means I'm looking at this one right here, okay? So I already know that y is going to be negative. Whatever I get here, it's going to have a negative value. Now let's put this into the unit circle. So x squared plus y squared is equal to 1. -2 root 5 over 5 squared plus y squared is equal to 1. Okay? Okay, here we go. Well, let's see. -2 squared is 4. Root 5 squared is 5. So 4 times 5 is 20. And then the denominator 5 squared is going to be 25. So this is going to be positive 20 25ths plus y squared equals 1. Now I could simplify this, but you know what? I can see right now I'm going to end up taking a square root in a little bit, and 25 has a beautiful square root. I'm just tempted to leave it like that. Okay? Because if I cancel a 5, you're going to end up with a 5 in the denominator. Yeah, right now I don't know if I want that. So I'm going to leave that looking in that form right there. So this will be 1 minus 20 over 25. So y squared is going to equal, what is that? Well, this would be 25 25ths minus 20 25ths. So y squared is going to equal 5 25ths. It looks like no matter what I do, I'm stuck with that. I'm going to be stuck with that root 5 in there. So now, maybe what I do at this point is I do simplify this to make it 1 over root 5. And I'm doing it this way. I know there's another way I could do this, but I'm doing it this way because, oops, sorry. I didn't mean to put that square root in there right now because I have the y squared there yet. Because this is going to allow us to have a little conversation in a second here. When I take the square root, this will be plus or minus root 1 over 5. But because I already know this is in the third quadrant, I know the y-coordinate is going to be negative. So this will simply be negative 1 over root 5. Now, you might not be allowed to leave it like that, though. You might. It might not be an issue, but you are very likely going to be expected to take this one step further here and rationalize the numerator denominator and make this negative root 5 over 5 when you multiply numerator and denominator by root 5. Okay? So it could be this, or it could be this.
Give the coordinates to 4 decimal places, of the intersection point of the terminal arm of a standard position angle of 4.8 radians and the unit circle.
So this question, although it's kind of wordy here, this really boils down to a very, very simple idea. Remember that a point on the unit circle, okay, so if we're looking at the unit circle, any point on it has the coordinates cosine of theta, sine of theta. Now, when we said that earlier, we did not specify that these had to be in radians or degrees, because it doesn't matter. So in this particular case here, this would simply be the cosine of 4.8, comma, the sine of 4.8. And now we just go to our calculator. Got to make sure that we're in radian mode. Okay, and so now the cosine of 4.8, whoops, 4.8, okay, 0.0875, 0.875, so there's the x coordinate, and the sine coordinate will simply be the sine of 4.8, negative 0.9962. 0.9962. And those are the coordinates that we're looking for. Just as straightforward as that. You got to memorize that. Okay, you got to be able to kind of go to that little bit of information right away when you're asked.
The point 2 over 3, comma, negative root 5 over 3 lies at the intersection of the unit circle and the terminal arm of an angle in standard position. Determine the values of the 6 trigonometric ratios for theta.
Okay, so this is the type of question you hope and pray shows up, okay, on the exam. Because if this is a point at the intersection of the unit circle and a terminal arm, if this is a point on the unit circle, then the cosine of my theta is going to be 2/3, which tells me immediately that the secant of theta is 3/2. I know that the sine of theta is going to be negative root 5 over 3, which means by default that the cosecant of theta is going to be negative 3 over root 5. Now, you may need to rationalize that, which would be negative 3 root 5 over 5. But the point is, immediately you know those values right there. Now, to figure out what the tangent is, okay, tangent of theta, and this is going to take me just a little bit more work here. Tangent of theta is always y over x. So this is going to be negative root 5 over 3 divided by 2 over 3. Now, when I'm dividing fractions, I'm going to multiply by the reciprocal. Oops. Don't know why I wanted to put 3 there. That's a 5. Root 5 over 3. We're going to multiply this by the reciprocal. Okay, 3 over 2. And then notice that the 3's cancel. And so I'm left with negative root 5 over 2. That's the tangent of the angle. Okay, now, but all 6 of them, so I need cotangent. But the cotangent is quite easy once we've got this. I'm just going to reciprocate that. So negative 2 over root 5. However, you might be asked to rationalize this, in which case that would become negative 2 root 5 over 5. And that's the last one.
The point negative 0.8480, comma, negative 0.5298 lies on the intersection of the unit circle and the terminal arm of an angle in standard position. Determine the angle to the nearest tenth of a radian.
So I'm going to show you 2 different ways of handling a problem like this. First of all, notice that this is a point on the unit circle. So this is the cosine of that angle, this is the sine of that angle. But more than that, I know that they're both negative. Okay, if both the x-coordinate and the y-coordinate are negative, I know that what I'm dealing with here is a third quadrant angle. Okay, and so I got to figure out what that is here. Now I know right now that the cosine of theta is equal to negative 0.8480. Now I could solve this using either the cosine of theta equals this or the sine of theta equals this, doesn't matter. What I'm going to do first of all is find the reference angle by doing the inverse cosine of positive 0.8480. Okay. Now, I'm going to make sure I'm in radian mode here. I'm going to use my calculator. So radian mode, and I am. And I will do the inverse cosine of 8480. 8480. Oops. Oh, I'm sorry, I didn't put the decimal there. 0.8480. And so I get 0.56. That's my reference angle. Now remember, I'm not going to use 0.56. I'm going to use the decimal that I'm provided right here. Okay? I know that I'm going into the third quadrant. So it's going to be down here. So in radians, remember, I go over pi to get to the x-axis, and I have to go that a little bit more to get to my terminal arm. That little bit more is the reference angle. So to get my answer, I'm going to take pi and I will add that reference angle. And that gets me 3.70, okay, or 3.7, because it says rounded to the nearest tenth. So 3.7. Now I want to show you another way of doing this. Okay. Take out your calculator and I want you to go, and we've done this before, I want you to go into your angle menu, so second apps, and I want you to go down to this right here. Now you don't really need to know what the R or the P stand for here, but it stands for rectilinear coordinates to polar coordinates. Okay, or sorry, from polar coordinates. Press, or anyway, it doesn't matter. I said that backwards, but anyway, once you've chosen that, what you do here is you simply enter in the coordinates as you get them, 0.8480, comma, negative 0.5298. And when I press enter, now it gives me a negative angle here. Now, because the calculator does something kind of neat here. The calculator is actually working from a domain of negative pi to positive pi. Now, if you want to get the angle that we're looking for here in the third quadrant, all I got to do is add 2 pi to that, and that's the answer that we got. Okay? So just a neat little tool that the calculator has for figuring out the exact same thing. Whoops, there it is over here, and the answer was 0.37 again. Oh, sorry, 3.7. Yeah, sorry.
In this section, we want to revisit the idea of assigning exact values to the trigonometric ratios for certain angles.
Okay, so for the next little while here, what we're going to do here is talk about a handful of angles that have really nice trig ratios to them. So nice that we actually don't really need a calculator to be manipulating them. Okay, now we're going to go back and review from Math 20. And remember, in Math 20 we looked at these special triangles here. So if you've got a 45-45-90 triangle, the legs of the triangle are 1 and 1, and then the hypotenuse is √2. Okay, this enables me to get the sine, cos, and tan, and really the reciprocal trig functions as well, for 45 degrees. Over here with the 30-60-90 triangle, okay, I remember that the hypotenuse was 2. This leg right here was 1, the one that was adjacent to the 60 degrees, and the one opposite the 60 degrees had a value of √3. And this enabled me to get all the primary trig ratios, and now you probably see how you can get the reciprocal trig ratios out of that for 30 and 60 degrees. So memorizing those triangles is actually a really useful way of getting that information here. Now, you also learned in Math 20, and that's what this next little paragraph's about here, about reflecting these triangles from one quadrant to the other. Essentially, you were developing the cast rule, and you might have built a chart that looks like this to kind of help you figure out, or to help you memorize those ratios there. And then once you've had either the ratios memorized in the chart or the triangles up here, you're able to find the sine, cos, and tan of these angles, even if they were in, or larger angles like 150 or 225, as long as the reference angle was one of these 3 angles here, you were fine. And that's essentially what we're going to continue to do here. However, what we want to do is give you another way of memorizing this information, okay? Something a little different than the special triangles or this chart. Okay? Nothing wrong with either one of those, but there is another way of doing this. Okay? Now, we're going to come over here and let's just take a quick look at these special angles here and how they can be worked around the full circle. So, if we start with a reference angle of 45 degrees, we're going to go from quadrant to quadrant because we want you to see all of the angles that you get here. 45 degrees in the first quadrant, remember this is going to be 45 degrees. Now when you come over here to the second quadrant, okay, where this is our angle. Remember, this is our reference angle. So this becomes 180 minus 45 degrees, okay, which is going to be 135 degrees to get to that terminal arm. Okay, now if we go around a little further out to here, this angle here hits 180, goes 45 degrees beyond. This angle here is going to be 225 degrees. And if we go even a little bit further and go all the way around out here to the fourth quadrant, okay, remember this is going to be 360, but we're going to be shy of that, 45 degrees, so we subtract, we'll get 315 degrees. Now, in radians, remember what radians do. Okay, if the angle here is pi over 4, that means I'm taking the top half of the circle and dividing it into quarters. So in this first case here, the rotation angle is exactly the same as my reference angle, so pi over 4, that's fine. To get to this one right here would be 1/4 of pi, 2, 3. So this will be 3 pi over 4, or 3/4 of pi to get to 135 degrees, same thing. To get down into the third quadrant, that's 1/4, 2, 3, 4, 5. So 5 pi over 4s is the same as 225 degrees. And to get you down into the fourth quadrant, that's 1, 2, 3, 4, 5, 6, 7. 7 pi over 4s will get you down to that terminal arm. Okay, so we just want you familiar with these angles as we go around the circle. Each of these is going to have its sine, cosine, tan, and so on related to 45 degrees. Now let's take a look at the set of angles you get when you're working with a reference angle of 30 degrees or pi over 6. So in the first quadrant, this is going to be 30 degrees. And then we come over here. Okay, and remember, you like overshoot the angle, hit the x-axis, then go backwards 30. And so that's going to be 150 degrees. We've already seen that actually a few times in this course. Into the third quadrant, we come around, we hit to 180, and then we go down another 30 degrees. So that's, whoops, I don't know why I wrote that, but this is going to be 210 degrees. And to get into the fourth quadrant, we come all the way around. And you might want to think about overshooting it to 360 and then coming backwards. But 360 minus 30 will give you 330 degrees. So those are the angles related to that reference angle of 30 degrees as you go around. Okay, so these are the important ones. And hopefully these will ring a bell when you're starting to work through the problems here. If we talk about this in terms of radians, okay, well, our reference angle is pi over 6, and we know that in the first quadrant it's the same as the rotation angle. So that was the easy one. But when you're talking about pi over 6, remember you're talking about chopping the top half of the circle into sixths, and then the bottom half of the circle into sixths as well. So to get to that terminal arm right there in the second quadrant, that's this guy right here, that's 1, 2, 3, 4, 5. This is 5 pi over 6's, lines us up with 150 degrees. To get into the third quadrant, I start here and I go around down to here. Now, to get to the same as pi there, that's 6 pi over 6's, then I go one more, so 7 pi over 6, lines us up with 210 degrees. And if I want to go all the way around to this guy right here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6's, because the 12th one will get me right back or line me up with 2 pi. So in radians, the angles I'm looking at here are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Another one, pi over 3, 60 degrees. So in the first quadrant, again, the reference angle is the rotation angle, so that's 60 degrees. To get to here though, okay, think about overshooting to get down to 180 and then come backwards 60. So that's going to be 120 degrees, 180 minus 60. To get into the third quadrant, okay, that's going to be 180, and then I got to go overshoot that by 60 degrees. So 180 plus 60 degrees will make it 240. or I can come all the way around into the fourth quadrant. Now I would overshoot and get to 360 degrees, but I'm going to come back 60, which is going to make this 300 degrees. Okay? Now, in radians, that reference angle is pi over 3. What that tells me that I'm doing is taking the top half of the circle and dividing it into thirds, which means I'm also doing it to the bottom half of the circle. To get into the second quadrant, right here, I need 2 pi over 3's. So 2 pi over 3 is the same as 120 degrees. To get us down into 240, okay, I need to go past, that's this one down here, that's 1, 2, 3, 4. 4 pi over 3's gets me down to that terminal arm. And to go all the way around to that 300, that's this terminal arm right here, that's 1, 2, 3, 4, 5 pi over 3's gets me into the fourth quadrant there. All right, so these are the angles that you want to be familiar with. Okay, now, what we're going to do with this is we're going to take all the information that we've just kind of put together on this page here, all these angles here, we're going to combine them with the cast rule and the information that we've got memorized either from this chart or from the special triangles, and we're going to put all of this together on this page right here. I'm going to zoom out a little bit here. Okay. Okay, so here we go. Now, these are points on, we're going to assume that this is the unit circle. So the coordinates of my points here, okay, will be the cosine of the angle and the sine of the angle. Now let's identify the angles, because we've just gone through them. So this would be, for example, 0 or 2 pi. Okay, whoops, sorry, actually I shouldn't do it like that. Maybe we'll do it like this. We'll say that this is right here is like 0 degrees or 0 radians. This would be 30 degrees or pi over 6 radians. This right here is going to be, actually I should probably I'll start with degrees here. This is going to be 45 degrees or pi over 4 radians. 60 degrees or pi over 3 radians. Right here, this would be 90 degrees or pi over 2. This would be 120 degrees, or what do I get, 2 pi over 3. This would be, what did I say here, 135 degrees, or 3 pi over 4. This would be 150 degrees, 5 pi over 6. This is hard to kind of just rattle those things off here, but we need to get all the angles here. This is 180 degrees, or pi. And now we just honestly just keep going here. So this is 210 degrees. This would be 7 pi over 6 radians. This is going to be 225 degrees, or pi over 4 sorry, or what do we got here? That would be 5 pi over 4 radians, comma 5 pi over 4. This one right here is going to be, well, this is 120, 180. So this is the 240, or okay, 2 pi over 3, 3 pi over 4 pi over 3 radians. And then down here, this would be 270 degrees, okay, or 3 pi over 2 radians. Coming around to here, right here, this would be 300 degrees, okay. Now, this was, what was this? Those are 5 pi over 3. This was going to be 315 degrees, which would have been 7 pi over 4. And this last one here is going to be 330 degrees, or 11 pi over 6. That's an awful lot. And I know that was long here, but the point is, you know all of those angles here. Now we're going to identify the points along the unit circle, and you already know this. First of all, we know that this coordinate right there is 1, 0. So there's the cosine, there's the sine. Now, the cosine here is going to be root 3 over 2. The sine was 1 over 2. The cosine here was root 2 over 2. The sine was root 2 over 2. The cosine here was 1 over 2. The sine here was root 3 over 2. And then up here we get the point 0, 1. And so those are the trig ratios. Okay. Over here, essentially all of these just reflect, but now the x coordinates are going to be negative. So negative 1/2 root 3 over 2. Negative root 2 over 2, root 2 over 2. Negative root 3 over 2, 1 over 2. Okay, then we get down here, this is negative 1 comma 0, and now these all reflect down here, but this time the y coordinates change. So this will become negative 1/2 negative root, sorry, reflecting the wrong thing. It's got to reflect this one. So negative root 3 over 2, negative 1 over 2. Negative root 2 over 2, negative root 2 over 2. And this will become negative 1/2 comma negative root 3 over 2. This becomes the point 0, negative 1. And then we reflect all of these over here. But this time, these x coordinates change from negative to positive. Okay, and so we're going to get here 1/2 comma negative root 3 over 2. Root 2 over 2 comma negative root 2 over 2. And then root 3 over 2 comma 1 over 2. Okay, whoa, I know that's long and there's a lot of information here. We want you to memorize this. Okay, we want you to memorize this. Now, on the next page, you see all of that has been done for us. Okay, all of this information is right here. I do want to show you something though, really quite clever here that another teacher showed me a long time ago. You already know the cast rule. Okay, you know the cast rule. Cosine, all, sine, tangent. That's what tells you what the sign on the trig ratio is. I want to give you a way of memorizing these things. Now, I'm not going to take the time right now to explain why this works here, but I am going to just throw down the numbers here. One way of setting this thing up for you is we're going to put everything over 2, even the 0 and the 1 and the 0 over here, and we're going to put square roots in all of the numerators. If you do that, then all you really ever have to do is write out this first quadrant and use the cast rule. Now, watch what happens here. If I put both of these points over 2, 0 over 2 is irrelevant. 1 over 2 becomes 2 over 2. And I'm going to put square roots in there. So this becomes root 0 over 2. Okay? And then this was over 2. To make this 1, this was 2 up here. So this, I want that to be 2 because I want this ratio to be 1. This is probably the most awkward one to do. That becomes root 4 over 2. Here, I can simply put a square root in the numerator there to get root 1 over 2, root 3 over 2. This point is exactly the way I want it, root 2 over 2, root 2 over 2. This one here, I'm going to put the square root over the 1. And so this is going to become root 3 over 2, comma root 1 over 2. And then over here, this point here is as ugly as the one up here. So remember how that 1, when the 1 was up here, became root 4 over 2? Well, I want to do the same thing here. I'm going to make this root 4 over 2, comma root 0 over 2. Now bear in mind, this is still 1, this is still 0. At first, this might look like I've made it more complicated. But now look at the pattern. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. I think that's pretty easy to memorize. Okay, so by quickly jotting something like this down on an exam, writing those out here, it's just pretty easy to memorize, and then memorizing the cast rule, you should have all the information you need to answer any of the problems you're going to get.
Give the exact values of the following. The cosine of 120 degrees.
Okay, so when I take a look at this now, granted I could use the whole unit circle to answer all of these problems, but I'm not going to do that. I'm only going to use the first quadrant because I want you all to get really comfortable with the idea of the reference angle. So what I'm going to do here is I'm going to take this and I'm going to reduce all of these down to their reference angles, okay? So cosine of 120. 120 is in what quadrant? 120 is in quadrant 2. So I know that cosine is going to be negative in quadrant 2. I know that in quadrant 2, I would subtract 120 from 180 to get the reference angle of 60 degrees. So the cosine of 120 is going to equal the negative cosine of 60. And now I think back to my unit circle. What is the cosine of 60? So go look at 60 degrees. What's the x coordinate at that point? And the answer is 1/2. So the issue here is the cosine of 120 is negative 1/2.
The sine of 210 degrees.
Now I'm just going to follow that same pattern that I established in the previous question and continue on here. So, first of all, look at the angle, 210. What quadrant is 210 in? It's in quadrant 3. Sine is negative in quadrant 3, so I know this is going to be equal to the negative sine of something. What reference angle do I associate with 210? That's a little bit beyond 180. In fact, it's 30 degrees beyond 180. So the answer here is the sine of 210 is equal to the negative sine of 30 degrees. And I know that the sine of 30, okay, if I look it up on the chart here, I look at the y-coordinate, okay, on the unit circle, that's a half, so the answer is negative 1/2.
The tangent of 315 degrees.
And now I continue the pattern. 315, okay, is in quadrant 4. Tangent is negative in quadrant 4. Okay. 315, if you were to add 45 to that, you get 360. So the reference angle here is 45. Now, from the unit circle, this is probably the more difficult one to read here. In this case, I am going to go up to the point here. I'm going to slide this up here. When you take a quick look at 45 degrees here, okay, you get root 2 over 2 comma root 2 over 2. This is the cosine of the angle. This is the sine of the angle. To get tangent, remember tangent is y divided by x. But root 2 over 2 divided by root 2 over 2 is just 1. So the answer here is this is going to be negative 1.
The cosine of 5 pi over 6.
All right. It's no more difficult when you're talking about it in terms of radians here. So 5 pi over 6. Now just think about this. 6 pi over 6 is pi. So that would be along the x-axis here. Now this is 1 short of that. That puts this in quadrant 2. Or if you have to memorize that, that's okay. But that puts us in quadrant 2. Cosine is negative in quadrant 2. And watch this. There's my reference angle. Okay, this is beautiful. All I got to do is cover up that number here. That's my reference angle. So this is the negative cosine of pi over 6. Pi over 6 is the, if you have to associate that, it was with 30 degrees. And so the x-coordinate at that point, which I associate with cosine, is going to be root 3 over 2. So the cosine of 5 pi over 6 is negative root 3 over 2.
The sine of 5 pi over 3.
We continue on. 5 pi over 3. Okay, pi over 3, I'm cutting up pi into thirds. Okay, and if I've got 5 of them, remember I'm starting here, that's 1, 2, 3, 4, 5. Oh, look at that, I'm in the 4th quadrant. Sine is negative in the 4th quadrant. The reference angle here is pi over 3. So this is going to be negative. Now, you have to go back up to that chart there, the unit circle here. What is the sine of pi over 3? What is the y-coordinate at that angle? And the answer is root 3 over 2. So the answer is negative root 3 over 2.
The tangent of 3 pi over 4.
In this case, 3 pi over 4. Okay, it's not quite a full pi, so this must mean we're in quadrant 2. Tangent is negative in quadrant 2. And the reference angle here is pi over 4. Now again, pi over 4 is a little goofy. Because, I shouldn't say pi over 4. Tangent's a little goofy because to get that I have to divide the y-coordinate by the x-coordinate. But in this case, at 45 degrees or pi over 4, they're both the same. They're both root 2 over 2. So again, this just becomes negative 1.
The cosine of negative 45 degrees.
So this question's a little different because our rotation is negative. Now, it's a negative acute angle, which means I get into the 4th quadrant, but I don't leave it. Well, cosine, I should say. Cosine is positive in the 4th quadrant, and a reference angle is an acute angle, so this is going to be the cosine of 45, the positive cosine of 45. Now, go to your unit circle. If you want to go to special triangles, because that's how you memorized it, that's fine, but the unit circle's fine too. And I'll take the x-coordinate of that point, and I get that that's going to be root 2 over 2. So the cosine of negative 45 will be positive root 2 over 2.
The negative sine of negative 7 pi over 6.
All right, this one's a little confusing because it's got the 2 negatives in there. But this negative is something that I deal with at the very end because it's multiplied up front here. So let's just cover that up for just 2 seconds. Now, negative 7 pi over 6. This is a negative rotation. So I'm chopping up pi into 6's. Okay, which means I'm chopping up the top half and the bottom half. This is a negative rotation, so I'm going to rotate negatively 7 pi over 6's. So that's 1, 2, 3, 4, 5, 6, 7. Oh, that puts me in quadrant 2. Okay, so this is actually going to be a positive thing. So this would be the same as the positive sine. The reference angle here, if you cover that up, is going to be pi over 6. However, there was a negative out front, and that negative is going to change that at the end here to a negative. Now, the sine of pi over 6, go look at your unit circle. Remember, it's the y-coordinate, and the sine of pi over 6 is 1 over 2. So the answer to this is that it's going to be negative 1/2.
The cosine of 180 degrees.
All right, I like when the question starts to look like this. 180 degrees, okay? Now, let's think about this. That's right here, okay? That is this angle right here. Well, the coordinates of that point are negative 1, 0. Now, and I had said this earlier in this chapter here, that I need you to associate cosine with the x-coordinate, sine with the y-coordinate. So in this case here, I need to associate cosine with this coordinate right here. So that means that the cosine of 180 degrees is negative 1. That's how you do that one. Really quite easy as long as you've made that connection between the trig function cosine and the coordinate x.
The sine of 0 degrees.
All right, here's another one similar to the one that we just did. Sine of 0. Well, again, let's take a look at that unit circle here. Here's 0. The coordinates there are 1, 0. And remember, I need you to be associating the sine ratio with the y-coordinate. So in this case right here, sine of 0 would have to be 0. That's another one. And if you get that, if you can make that connection, makes these kind of questions very easy.
The tangent of 3 pi over 2.
Now, once again, to answer this one here, I need to know what this angle is here. And the helpful thing about this is if you cover up that coefficient here, I get that my now quote-unquote reference angle. Now, this isn't exactly true. You don't really want to think of this as a reference angle because a reference angle is by definition acute. Pi over 2 is 90 degrees. So it's not really that I'm using a reference angle, but I am, as a result, because that's related to 90 degrees, I am looking at the axes here. 3 pi over 2's puts me all the way down here. So I'm on the y-axis, okay, pointing down. Now let's take a quick look at the unit circle. The coordinates down here, okay, will be 0, negative 1. Now tangent is the y-coordinate over the x-coordinate. Now I wrote that out in this case because I want you to see this. That's division by 0. Well, that means that this is undefined. Yeah, the tangent of 3 pi over 2 is undefined. Cosine and sine are the only two of those 6 trig ratios that will not have values where its result is undefined. All the other trig functions will. So it's just something to get used to.
The cosine of negative pi over 2.
Okay, so now here, recognize that pi over 2 is like 90 degrees. But again, that negative in front indicates a negative rotation. So starting on the positive x-axis, I'm rotating this way. So again, I'm on the axis. Let's take a look at the coordinates here. The coordinates of that point right down there are going to be 0, negative 1. And this is cosine. So remember, I associate cosine with the x-coordinate of a point on the unit circle. And in this case, the answer is 0.
The sine of 270 degrees.
Okay, let's take a look at 270. And we've already done this question, but not specifically this one, but certainly taken a look at this. 270 degrees is on the y-axis here. So again, let's take a quick look at that point, because the coordinates of the point on the on the unit circle give us the cosine and the sine. I'm asking you for the sine of 270. Look at the coordinate, the y coordinate there, -1. Sine of 270, -1.
The tangent of 2 pi.
This one here might be a little bit confusing, but if you haven't already put together and you're comfortable with what 2 pi represents. Okay, so 2 pi, remember, that's your full rotation. That's basically making us coterminal with 0. So that angle is on the x-axis. The coordinates over here are going to be 1, 0. And remember that tangent is the y-coordinate over the x-coordinate. So in this case, it's quite simply 0 over 1. The tangent of 2 pi is necessarily 0.
The sine of 495 degrees.
Okay, now this question is a little bit different here. Once we start going and getting angles that are beyond the 0 to 360 or even the 0 to -360, we need to start to dial that back, okay? Because remember, all coterminal angles will have the exact same sine, cosine, and so on here. So what I got to do here is I got to dial this number back here. I know that this will be exactly the same as the sine of. Now this angle is bigger than 360. I want the principal angle, so I'm going to subtract 360 from that, and I get the sine of 135. Now, are those two the same angles? No. But because they're coterminal, they will have exactly the same sine value, or actually sine, cosine, and tangent. Now, this is where I take a little bit of a harder look at the 135. That is in quadrant 2. Sine is going to be positive in quadrant 2, so this will be equal to the sine of, and the reference angle here is 45. Now I look to my unit circle or my special triangles, however you're going to go about doing that, and you should get that the sine of 45 is root 2 over 2. So that is also the sine of 495.
The cosine of -600 degrees.
So here's another example of an angle that's basically outside our typical domain here. So what I've got to do with this is I've got to bring this back in. So what I'm going to do is I'm going to add 360 to this. And when I do that, I get -240. Now, this might be actually good enough for me to work with. I could add, if I wanted, another 360 to that and make that a positive. You know what? That's maybe not even a bad idea. I'm just going to do that. I'm going to add 360 to this one as well. And this is going to get me the cosine of 120. You know what? Instead of fighting to make that -240 work and kind of thinking backwards here, all I need are coterminal angles. Let's do it. So I know that the cosine of -600 will be identical to the cosine of 120. Now, cosine of 120, 120 is in quadrant 2. Cosine is negative in quadrant 2. Okay. What's the angle between 120 and 180? That's going to be 60 degrees. The cosine of 60, look at your unit circle. Because it's cosine, I'm asking for the x-coordinate. This is going to be -1/2. So the cosine of -600 degrees will be -1/2.
The secant of 150 degrees.
Now we're taking a step in a different direction. Now we're going to take a look at the secant. Okay. Now the way to do this one here, honestly, is just to look at the reciprocal here. Secant is 150. Let's just take a look at the cosine of 150, but understand that this is reciprocated. Okay. Now 150. 150 is totally in quadrant 2, so I know this is going to be equal to the negative cosine of, well, what's the reference angle for 150? Compare that to 180 because I'm in quadrant 2 and it's going to be 30 degrees. So this is 1 over negative, okay, what's the cosine of 30 degrees? So either look at your unit circle or whatever, look at the x-coordinate. It's root 3 over 2. Okay, now I'm almost done, not quite done. I've got 1 over negative root 3 over 2, so this is going to equal, okay, I'm going to multiply by the reciprocal, so it's going to be -2 over root 3. But I'm still not quite done because I'm probably going to be expected to rationalize that, which means I've got to multiply numerator and denominator by root 3, so -2 root 3 over 3, that's the one that I'm looking for.
The cosecant of 11 pi over 6.
Okay, so seeing that this is cosecant, I'm going to do basically the same thing I did in the previous question, but this is going to be 1 over the sine of 11 pi over 6. Yeah, I'm going to change that. 11 pi over 6. Now, 11 pi over 6. I could look at my unit circle, or I could just think of it like this. I've got 11 pi over 6s. Now, how many pi over 6s are there in the full circle? Well, if I'm chopping the top half into 6, the bottom half into 6, that's 12. And I've got 11 of them? Well, that's got to be putting me in the fourth quadrant. Okay, now if you're not clear on what I'm doing there, I'm chopping up the whole circle, the top half into 6, the bottom half into 6. I've got 11 of them as a standard, rotation angle in standard position. It's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. That's got me going all the way around here. Sine is negative, okay, in the fourth quadrant, and the reference angle here is just going to be pi over 6. Now, that's 1 over the sine of pi over 6. Okay, I'm looking for the y coordinate there, or go to your special triangles. This is going to be 1/2. But 1 divided by negative 1/2, just multiply by the reciprocal, and we'll get negative 2. That's a nice one because I don't have to do anything else to it. It's good.
The cotangent of 0 degrees.
All right, so now cotangent. Now cotangent of 0. Okay, so we're on the x-axis. The coordinates right here are going to be 1, 0. This is going to be 1 over the tangent of 0. Actually, you know what? For consistency's sake here, I'm going to try to help you guys avoid an issue here. When you're doing this right here, don't think of it as 1 over tangent. Okay? Think of cotangent as x over y. I'll explain why in just a second here, but take a quick look at this. Cotangent is x over y. That's going to be 1 over 0. Okay? And so in this case, we know that this is going to be undefined. The reason why this becomes a bit of an issue here is when you take a look at the cotangent of 90 degrees. If you take a look at if you treat that as 1 over tangent, then you get 1 over the tangent of 90, but the tangent of 90 is undefined. And 1 over undefined is still undefined. Okay, 1 over I don't know is still I don't know. But if you treat cotangent as just x over y, then at 90 degrees, you're going to get that it's equal to 0. So I think for a more consistent definition here, I think you should be, for cotangent, at least, just for cotangent, think of that in terms of its definition, x over y.
The negative secant of negative 7 pi over 4.
Okay, here's another problem with the two negatives there. Let's not worry about that negative in front just for a little while here. So this is going to equal, okay, there's that negative out front, 1 over the cosine of negative 7 pi over 4. Okay, now, first of all, again, ignore that negative out front there. It's still there, but I don't want to worry about it right now. This is 1 over, okay, negative 7 pi over 4. So I'm rotating in the negative direction, and I'm dividing pi into quarters. So that's 1, 2, 3, 4, 5, 6, 7. Okay, that puts us in quadrant 1. Well, cosine is positive in quadrant 1. And the reference angle here is easy to see. That's pi over 4. I just cover up the coefficient. But there's still that negative out front. Now, I go look this up. Cosine of pi over 4 is root 2 over 2. Okay, which means this is going to equal negative 2 over root 2. Now, you can rationalize this to simplify it if you will, but when you divide 2 by its square root, you get its square root. Now, if that's not clear to you, you really need to just stop and think about that. If you take a number and divide it by its square root, what do you get? What's 16 divided by 4? 4. What's 9 divided by 3? 3. What's 100 divided by 10? 10. So what's 2 divided by root 2? Root 2.
The cosecant of 180 degrees.
So here, the cosecant of 180, we're going to rewrite that as 1 over the sine of 180. 180, okay, is on the x-axis over here. And so the coordinates at that point will be negative 1 comma 0. And remember how this works here. Sine is associated with the y coordinate. So this is going to be 1 over 0. So the answer here is that the cosecant of 180 is undefined. Okay? And as I mentioned before, this happens for most of the trig functions, just not for sine or cosine.
The square of the sine of 120 degrees.
Now, this question is about getting used to this notation. Okay? We put the square there, or when the square is there, I should say. What this means is the sine of 120 degrees squared. Evaluate the sine of 120 first, then square the result. If you put the square here, you're talking about the angle. Okay? Now, if the square is inside there, you're talking about the angle. If the square is outside, actually, it's still referring to the whole thing. That's the notation your calculator uses. When you want to square something in a calculator, typically you put the square out here. But this is customarily the way we write this. Now, I just got to figure out what this is. 120 is in quadrant 2. Sine is positive in quadrant 2. The reference angle is 60 degrees. I look that up. Okay, or I got to just think about it here a little bit. Sine of 60, that's the y coordinate. That's going to be root 3 over 2 at 60 degrees. And when I square that, root 3 squared is 3, and 2 squared is 4. Whoops. So my answer is 3/4.
The square of the cosine of 330 degrees plus the square of the sine of negative 240 degrees.
Now this question's similar to the one that we just did. It's just that there's more of it here. Okay, so this is the cosine of 330 all squared plus the sine of negative 240 all squared. Whoops, sorry, can't quite see that. So now let's just take a quick look at this. 330 is in quadrant 4. Okay, well, cosine is positive in quadrant 4. And the reference angle, compare 330 to 360, and the answer is 30. So that's all squared here. Plus, all right, negative 240. Oh boy, negative 230. Starting on the, right, out here, that's negative. That's going to put us in the second quadrant right here between negative 180, negative 270. So I know that this is going to be positive, and that's going to be the positive sine of, well, the reference angle for 240 is 60 degrees. Okay, so the cosine of 30 degrees, okay, that's the x coordinate on the unit circle, will be root 3 over 2. The sine of 60 on the unit circle is the y coordinate. That's root 3 over 2 at 60 degrees. So this is going to be 3 over 4. This will be 3 over 4. And putting that together, that is going to be 6 over 8. Sorry, I cannot believe I just did that. Don't do that, ever. Oh my gosh. Okay, I'm obviously very tired. That is 6 over 4. Divide both of those by 2, you get 3 over 2. Oh my goodness, don't tell your teachers. Lose my job. You never add fractions like that.
The sine of 5 pi.
Okay, that 5 pi there, that's an interesting angle. Let's just talk about this for a second here. Okay, here's 0. Pi, all on its own lonesome is over here. This is pi. This is 2 pi. Now, just keep following that pattern. This is 3 pi. This is 4 pi. This is 5 pi. Notice that that leaves us on the x-axis, but on the negative x-axis. Now, on the unit circle, okay, when you take a look at the unit circle out there, what coordinates are this? Well, this is the point negative 1, 0. Sine is associated with the y coordinate, so the sine of 5 pi would be 0.
The square of the secant of negative 5 pi over 6 plus the cotangent of 5 pi over 3.
So for a question like this, you really just need to take this in steps here. Okay, so secant squared of negative 5 pi over 6. This is 1 over the cosine of negative 5 pi over 6. This is all going to be squared. And in this case right here, I might flip this and make this 1 over the tangent of 5 pi over 3. Okay, now this is 1 over, let's just take a look at what's going on inside here. Negative 5 pi over 6 means, okay, we're cutting up the circle into 12. and I got negative 5 of those. So that's 1, 2, 3, 4, 5. That's this way right here. I'm in the third quadrant. So cosine is going to be negative in the third quadrant. The reference angle, and I'm going to do this a little more quickly right now. I know that the unit circle is going to be pi over 6. So I know that the cosine is going to be, the reference angle is going to be pi over 6, and the cosine will be root 3 over 2. So this will be negative root 3 over 2 squared. Okay, so negative because it's in the third quadrant. Over here, 5 pi over 3. Well, that means I'm chopping up the top half and the bottom half into thirds. 5 pi over 3 is 1, 2, 3, 4, 5. I'm in the fourth quadrant. Okay, this is going to be negative. The reference angle is pi over 3. The tangent of pi over 3, okay, the tangent of pi over 3 is going to be the y-coordinate divided by the x-coordinate of that point on the unit circle, or you can use your special triangles. However, the point being is that that's going to be equal to root 3. Now, this becomes 1 over, okay, the negative squared becomes positive, so this becomes 3 over 4. This becomes negative 1 over root 3. Now, I'm going to come up over here to continue doing this. 1 over 3 over 4 is just 4 over 3. Minus 1 over root 3. I'm going to rationalize that to get 4 over 3 minus root 3 over 3. And because the denominators are the same, I can write 4 minus root 3 over 3. That's the final answer for this question. Okay, so 4 minus root 3 over 3.
The cosecant of 7 pi over 6 minus the cosine of 11 pi over 6.
All right, so this will be our last question here, last example that we do. Now, in this case, I've got the cosecant of 7 pi over 6. I'm going to make this 1 over the sine of 7 pi over 6. And I really don't have to do much with the cosine here, except it's 11 pi over 6. Now, let's think about that. We've seen this before. We know that that's in the fourth quadrant. So cosine is positive in the fourth quadrant. Now, that negative is in front, so that negative is going to come later. So I'm not going to change any signs here, though, because cosine will be positive. And the reference angle here is pi over 6. Here, 7 pi over 6, okay, 7 pi over 6, this is going to put us in the third quadrant. Sine will be negative in the third quadrant, and the reference angle is pi over 6. Now, over here, I can look this up. The cosine of pi over 6 will be root 3 over 2. Then I can move down here. I can look up the sine of pi over 6, and that's going to be 1 over 2. That's the y-coordinate. So there's not much more I can do with that term right there at this point. Now, I'm going to simplify this. 1 over negative 1/2. Okay, I'm dividing by a fraction, so you multiply by the reciprocal. That'll be negative 2 minus root 3 over 2. There's really nothing wrong with that answer. However, I feel very tempted to put these both over 2 and make this negative 4 minus root 3, just to combine those together. So the answer here, as I would write it, would be negative 4 minus root 3 over 2. And that's the answer that, whoops, sorry, can't see that. That's the answer that I'd like to leave that as.